working on some notation today. So nPr is n factorial over n minus r factorial. nCr is n factorial over n minus r factorial divided by r factorial. When you do the permutation, which is ordered, you always get a bigger number than the corresponding nCr. Reason is, with choosing, you have to divide. What we're really doing is we're just choosing r out of n, but not ordering them. And that's why it's divided by r factorial, because the r factorial orders the ones that are chosen. So if you're trying to remember the formulas, the nCr would be the one that gives you the smaller value, so it's divided by r factorial as well. Okay? And obviously, nCr times r factorial gives us nPr. So if you take this one here and you times it by r factorial, you get the nPr. Now, we sort of did that in one of our questions. Instead of doing nPr, in one of our questions, we did nCr times r factorial, all right, with that odd thing in the circle. But you won't really use that. You just notice that from those. N factorial is n times n minus 1, n minus 2, all the way down to 1. And 0 factorial is 1 by definition. Now, if I asked you to simplify 9 factorial over 6 factorial, we're going to do something called rolling down. 9 factorial is 9 times 8 times 7 times. Now, I know I would stop and I'd say, well, it's times 6 all the way down to 1. Why did I stop at 6? Because my denominator is 6 factorial. And I can now cancel between numerator and denominator. Do we get that? Okay. Now, that is with numbers, but I'm going to ask you to simplify this. So what we're going to do, so n is greater than r, so n might be 20, r might be 16 or something, all right? We just don't know what they are, but all I know is that n is bigger than r, so r is going to be one of the numbers below n. Do you sort of get that? All right, now the actual question says, not to simplify, but it says to show, is to show that n factorial over r factorial is n times n minus 1 times n minus 2 times n minus 3 times times r plus 1. That's what it's saying. Now, let's have a look. If I know that n is bigger than r, isn't n factorial n times n minus 1 times n minus 2 times n minus 3, I could keep going. Sorry. If n is, like I said, something like, so we've got n factorial is n times n minus 1 times n minus 2 times n minus 3. Now we know that r is less than n. So r will appear somewhere down here. Yes. So we're going to put an r in. What do you think comes before the r? R plus 1. That's better, right? So because r is less than n, it will appear somewhere in that roll down sequence. Does that make sense? So n minus 1, n minus 2, n minus 3, r is going to appear, but the number before r is r plus 1. What's the number after r? R minus 1, r minus 2 times ... 3, 2, 1. All right, now I don't know if it's going to be 3, 2, 1. It just depends how big r is, depends how big n is. But it just shows the idea. So r will appear somewhere. Do you get that? R plus 1 is the one before it. Now r factorial is r times r minus 1, r minus 2 times all the way down to 3, 2, 1. Now do we see what's going to cancel? Everything. So the r times r minus 1 times r minus 2. What I could have done here is actually just written that as r factorial, but that's okay, because guess what? That and that all cancel. Do you see? So I could have, which is, and we're asked to show it, so you really should write it all, which is n minus 1 times n minus 2 times n minus 3 times, you will stop at r plus 1. So that r plus 1 is meant to be here in the question. I just didn't have room to write it on the same row. Now, let's just see how that works. I'm just going to show you with a few numbers. And this makes sense because if you look at the question above, right? Do you get that? If you look at the question above, 9 factorial over 6 factorial is 9 times 7 times 6. It's one number above the 6. If I did 10 factorial over 7 factorial, that would be 10 times 9 times 8 times 7 factorial over 7 factorial. The 7 factorials cancel. That's 10 times 9 times 8. So it's always one above the factorial of the denominator. So's this. 1 above r is r plus 1. So you roll down all the way down to r plus 1. Do you get that? Yeah. All right, so we just saw it here with this and this example. Okay? Now, the last one, n factorial over n minus r factorial is n times n minus 1 times n minus 2 times n minus 3 all the way down to n minus r plus 1, which is what we just did before, except before we had an r factorial on the bottom instead of an n minus r factorial. So let's start. N factorial over n minus r factorial. Isn't n factorial n times n minus 1? We better keep going. Times n minus 2 times n minus 3 times... Now, n minus r, where... Oh, no, I've got that. Where n is greater than r. N minus r is going to be one of the numbers down the path. And so is r. Because, for example, look, if I have 20 factorial over 12 factorial, 12 factorial will be one of the numbers. 12 will be one of the numbers down here, and so will 8. Do you get what I'm trying to say? 12 is the, let's say in this case, the n minus r, but 20 minus 12 is 8 will be one of the numbers down here as well. All right, so that the numerator is n times n minus 1 times n minus 2 times n minus 3. Now we want to have an n minus r plus 1. Now n minus r will be in there. So will n minus r minus 1, etc. And all the way down to 1. But one number bigger than n minus r is n minus r plus 1. So when I roll n down, because n is greater than r, I'll get n times n minus 1, n minus 2, n minus 3. N minus r will be there, so the number above it will also be there, n minus r plus 1, and the one below it will be, and 2 below it, and I have to roll down from n minus r all the way down to 1. That's 3 times 2 times 1. Over. Now n minus r factorial is n minus r times, go, n minus r minus 1, etc. Down to 3, 2, 1. These cancel. The n minus r downwards cancels, and you're left with what you're trying to show. Okay? And n minus 1, sorry about that, n minus 2, n minus 3 times n minus r plus 1. Okay? Get the idea? We're going to do some more. Show that 8p3 over 3 factorial equals 8p5 over 5 factorial. Now, I'm just going to write the definition. nPr is n factorial over n minus r factorial. It's not over r factorial again because that's the C one. So, we have to prove this. Let's go. 8p3 over 3 factorial. Isn't that... What's 8p3? 8 factorial over... Go. How do you use the definition? Over 8 minus 3 factorial. So that's the 8p3 divided by 3 factorial. You okay with that? This is 8p3 because it's 8 factorial over 8 minus 3 factorial. See, there's the definition of nPr. I'm following the definition. Now, isn't that 8 factorial over 5 factorial? If you're dividing by 3 factorial, isn't it times 1 over 3 factorial? Which puts it down here. Now, really, that is just... Can't I now write this as 8 factorial over... I'm trying to show that it's 8p5 over 5 factorial. I'm going to keep... What's 8p5? Well, I'm just going to rewrite this. Just watch. Isn't that 8 factorial over 5 factorial times... Isn't 3 factorial 8 minus 5 factorial? All right, I'll start. I'm trying to rearrange this to get that now. All right, no, I won't. Just wait. I'll just start again. I'll just do the same with the other number if you don't like that. Now starting again, so stop, start. 8p5 over 5 factorial, let's go. What's that? 8 factorial over 8 minus 5 factorial divided by 5 factorial. Do you get that? Which is 8 factorial over 3 factorial times 5 factorial. Aren't they the same? Yes? So, therefore, 8p3 over 3 factorial equals 8p5 over 5 factorial. You okay with that? So I've just evaluated 8p3 over 3 factorial. Because when you divide by 3 factorial, you times by 1 over 3 factorial. Is that okay? When you divide by 5 factorial, you times by 1 over 5 factorial. Now we're going to do the general. See this next one? It's the same as the first one, but in N and R general terms. All right? You okay? If you want to show full working out, I'll do it here. So that is, so dividing by 3 factorial is the same as timesing by 1 over 3 factorial. Dividing by 5 factorial is timesing by 1 over 5 factorial. Are we okay? Which is 8 factorial over 5 factorial times 3 factorial. And this is the same, 8 factorial over 3 factorial times 5 factorial. They're identical. Okay, now let's look at the next one. Prove that nPr over r factorial equals that. Let's start with the left-hand side. nPr over r factorial. nPr is n factorial over n minus r factorial. Now, because I don't want to do fraction divided by fraction, divided by r factorial. You okay with that? Which is the same as n factorial over n minus r factorial times 1 over r factorial, because that's divided by r factorial over 1. When you divide by a fraction, you multiply by its reciprocal, which happens to be n factorial over n minus r factorial times r factorial. Do you recognize that? That's nCr. That's nCr. Now, it says show, prove that this, which we've done, equals this. So let's just do the same with the other side now. np n minus r over n minus r factorial is, we're going to manipulate this and get the same. I'm going to say that that actually equals nCr. Is that all right? You okay with that? Let's show that this is nCr and then they're equal to each other. All right, how do you do this? N factorial, by definition, I've got to do the top one minus the bottom one. N minus, double brackets please, n minus r factorial. You okay with that? Because isn't nPr n factorial over n minus r factorial? So this np n minus r is, wait, I need double brackets, double brackets. So it's that factorial over that minus that factorial divided by this. Yeah, because I'm doing that minus that. I'm doing, do that minus that. So it's n factorial over n minus r factorial. I have to put the n minus r bit in brackets because I've got n factorial over what? N minus n plus r factorial. Do you get that? Times 1 over n minus r factorial, which is, what's this? N factorial over, what's n minus n plus r? R factorial times n minus r factorial, which happens to be the same as what you got there. Do you get that? So therefore, nPr over r factorial is equal to np n minus r over n minus r factorial. Prove that this is the n plus 1 is up in the corner here. N plus 1 pr equals npr plus r times npr. This little r minus 1 is down there. Now we know the definition. I'm going to write it over here. nPr is n factorial over n minus r factorial. It's just the top one factorial over the top minus the bottom factorial. That's the rule you've got to use. So let's use that rule. N plus 1 PR is what? Use the rule. Copy the bits for bits. What do you put? N plus 1 factorial over top minus bottom. N plus 1 minus factorial. That's what that is. And you can even write that as, it might be better to write it as n plus 1 factorial over n minus r plus 1 factorial. Okay, it's better to put the plus 1 on the end. Let's look at the other side. nPr plus r times nPr minus 1. So that's our left-hand side. Here is our right-hand side. nPr is n factorial over n minus r factorial plus r times, know what to do here? N factorial over n minus, you need brackets, r minus 1 factorial, which is, are you okay with that? Because it's that over that minus that, r times that over that minus that. So it's n factorial over n minus r factorial plus r times n factorial over, isn't this n minus r plus 1 factorial? Now, I need to make a common denominator. So I need this to be one bigger. So I'm going to times this first one by n minus r plus 1. You okay with that? So I took this first fraction and multiplied it by one bigger than I multiplied, isn't n minus r plus 1 bigger than that? So I've multiplied the numerator and the denominator both by n minus r plus 1. Do you know why? So I'm trying to get a common denominator with this. Plus r times n factorial over n minus r plus 1 factorial. Now, isn't this denominator n minus r plus 1 factorial now? Look, it's n minus r plus 1 times one number smaller than it factorial. So this numerator here now is n factorial times n minus r plus 1 factorial, and this is n minus r plus 1 factorial. Why? Because n minus r plus 1 is 1 bigger than n minus r. So this is like 8 times 7 factorial is 8 factorial. Plus r times n factorial over n minus r plus 1 factorial. Now, I've got the denominators the same. Now, I just need to take out n factorial as a common factor on the numerator. So it's n factorial, n minus r plus 1 plus r over n minus r plus 1 factorial. So what I've got here is a common factor on the numerator. Pull it out. And now simplify what I've got here. N plus 1. Now what's that numerator equal to? What's n plus 1 times n factorial? N plus 1 factorial. Isn't n plus 1 bigger than n? So it's n plus 1 times n minus 1 times, yes? So that's n plus 1 factorial over n minus r plus 1 factorial, which is what the other one was. So we've proven it.